Today on How It's Made. Glass bottles. Clearly fascinating. Hacksaws. We're off to a tool factory that's a cut above. And ice hockey goalie masks. Making them is a face-saving endeavour. But first... glass is made of natural ingredients that are abundant. Making it uses less energy than producing metal or plastic, and it can be endlessly recycled. Whether they're coloured or clear then, glass bottles and jars are always green. The recipe for glass combines several natural raw materials. The main ones are silica sand, soda ash and limestone. Silica sand usually makes up about 45% of the batch. The soda ash helps melt the silica evenly. It makes up about 15%. A limestone content of about 10% makes the finished glass more durable. These ingredients are combined with recycled glass called cullet. The factory's equipment feeds precise amounts of the materials into a furnace. After 24 hours at 1500 degrees Celsius, a gooey liquid that's the consistency of honey is produced. The molten glass pours out of the furnace. Shears cut the flow at precise intervals to produce cylindrical globs. Each glob is the exact amount required to make up one bottle or jar. They drop to a device called the scoop. The scoop moves them to troughs that feed them to jar-forming and bottle-forming machines. A glob of molten glass goes into a preliminary mould. In a matter of seconds, it comes out as a miniature version of the bottle, known as a parison. Each parison then moves into a blow mould, the cavity of which is the shape of the final bottle. The equipment blows compressed air into the parison, stretching the glass outward towards the wall of the mould cavity. This process creates the final bottle shape and hollows out the inside. These are amber-coloured beer bottles. The colour is produced by adding small amounts of iron, sulphur and carbon to the glass mix. A similar manufacturing process is used to produce other types of bottles and jars. In this run, the company is making 375 millilitre wine bottles out of clear glass. This run is producing bottles also out of clear glass. This mould though has a special feature, a recessed insignia on one of the walls, which produces a raised insignia on the front of the bottle. After the bottles leave the forming machine, they travel through flames. Otherwise, they would cool down too quickly and crack from thermal shock. A loader now gently pushes the bottles into what's called an annealing layer. The bottles cool at a controlled rate as they move through the layer. This gradually releases the stress from the glass. As the bottles exit, they're sprayed with lubricant. This enables them to move smoothly through the rest of the inspection and packaging line. The bottles now single file to head into the automatic inspection station. As the machine spins each bottle, cameras and probes check for imperfections such as cracks or bubbles. The inspection equipment then examines the top to check dimensions and ensure the threads for the screw cap are moulded correctly. Before shipping, each bottle gets a final visual inspection. The proportion of cullet in glass can be as high as 90%. Cullet melts at a lower temperature, so for every 10% of cullet in the mix, the factory uses up to 2.5% less energy to produce its glass. Now that is a clear incentive to recycle. From big saws to jigsaws, handsaws to bandsaws, even backsaws to hacksaws, all these tools have their specific purpose. Hacksaws are chiefly for cutting metal or other tough materials. So what is it that gives them their cutting edge? Hacksaw blades are made from a wide range of steel alloys. Here, a thin band of steel feeds into a machine that cuts it into blanks of 30 centimeters long and 1.3 centimeters high. The blanks are loaded into a jig, 300 at a time, where they're compressed into a block for easier cutting. The block is then fed into a machine called a mill grinder. It cuts teeth into the upper side of the blanks. A water-based lubricant washes away the metal particles. This hacksaw model has a 24-point blade. There are 24 teeth every 2.5 centimeters. A brush is used to remove any metal residue. The quality control department inspects each blade for flaws. Then it's off to the next phase. A separator detaches each of the 300 blades, aligns them, then sends them through a setting machine. The machine bends the teeth to either side at a slight angle. This is called offsetting. It will enable the blade to clear away particles as it saws, preventing it from jamming. Now it's time to harden the teeth. The factory does this by heat treating the metal. A worm gear aligns the blades to enter a heating coil. In this process, the electromagnetic heating coil heats the teeth to temperatures as high as 1200 degrees Celsius, depending on the type of metal. This takes no more than 2 seconds. After the blades exit the heating coil, the surrounding air cools them down over the next several hours. This phase is called air quenching. The blades are now ready for printing. An offset printing press applies ink to raised lettering on a cylinder. That cylinder transfers the ink to strips mounted on another cylinder. These strips then print the company name, the blade length, and the number of teeth per inch on the side of the blades. Now, a machine inserts the blades in groups of 5 into slots, called fingers. The fingers rotate the blades and place them on a conveyor belt. The machine raises the blades and tapes them together. This makes it easier to transport them to another part of the factory, where production continues. Next, the hacksaw's frame, the component that holds the blade, is made. The frame's components are placed in a jig that's positioned on a rotating carousel. A robotic welder fuses the components. A press punches 3 holes in the handle for attaching a foam or plastic grip. The 2 halves of the grip are fitted into a sonic welder that fuses them using high-frequency sound waves. The sound waves create friction at the seam, and this generates enough heat to melt the parts together. Now the frame is ready for the blade. An automatic device tightens a wing nut to put tension on the blade. Randomly selected blades receive a final quality control check. The testing machine cuts through a block of stainless steel. The machine performs this test 6 times per blade. Then the computer calculates the average number of strokes. If that average falls within the norms for this particular model, the batch gets the thumbs up. Keeping those thumbs, of course, well clear of the blades. Coming up on How It's Made, it's a 2-part special looking at how you can save face on the ice. Jolly hockey sticks. See you after the break. It's not just their protective shell and cage. Their wild paint jobs are designed to intimidate. Incredibly, back in the 1960s, the first goalies to wear masks were ridiculed by fans who viewed them as a sign of weakness. Today, though, ice hockey goalie masks are all about putting on a brave face. These masks allow the goaltender to play it safe, so they're far less likely to be sidelined by a serious injury. Production begins with a plaster mold of an average person's face. The mouth hole is plugged with plasticine. This ensures that the mold won't leak when it's filled with plaster of Paris. It's left to dry for half an hour. Then, the initial mold is pulled off to reveal the solid impression. Plasticine is pressed onto strategic areas. This mimics the foam safety guards that cushion every mask. The final result is called a plug, and it will be used to make a 2-part compression mold. After a black sealer is applied, it's polished smooth, eliminating imperfections that would be visible on the mold that will be made from it. Over at another station, fiberglass fabric is unrolled and cut into sheets, which are layered. A pattern is drawn on the top sheet. Spacing the shapes closely together minimizes waste. The goal is to create 100 masks from one roll of material. A disc cutter slices through 25 layers of the fiberglass fabric. Then, various composite fabrics are stacked, including several fiberglass ones and patches of Kevlar for reinforcement. Kevlar can absorb so much impact, it's used to make bulletproof vests. More fabric is placed over the Kevlar. An epoxy resin is spread onto each layer. They are draped over a mold that's been made from the plug. And the material is smoothed to eliminate air pockets, as they are then layered and glued. The ragged edges are trimmed away. Then, the inside portion of the mold is placed into the outside one. The wet fabric is now sandwiched between 2 mold pieces. A 1-ton press is lowered to compress the layers of fabric, as the resins between them continue to form a bond. Clamps are added to keep things tight. After 20 minutes, the laminated fiberglass shell is prized from the mold. The shell is now extremely rigid. It's the raw form of a goalie mask, but it still needs a lot of work. It's over to the trimming and grinding station. A trim jig is placed over the shell. A high-speed router is used to cut an opening for the cage. The flash is sliced off with a disc grinder. The edges are sanded and ground. Holes are drilled, which will be used to attach various fasteners. Larger holes are carved out. These aid ventilation and reduce the mask's weight. The mask is almost complete, but it still needs a snazzy paint job. The makers of ice hockey goalie masks have turned safety into an art form. The mask has become a canvas for some very bold designs and colours. It's a psychological tactic to intimidate the other team, and it scores points with the fans who like the cool paint jobs. The mask is roughed up with an orbital sander to prepare it for painting. Then a sealer is poured into a container. The technician wears a safety mask because the emissions are toxic. He adds the activator solution and a reactive reducer and stirs the sealer together. Then he sprays the sealer mix onto the masks. The finish will cure and harden as the chemicals in it generate their own heat. Next, a vivid gold base coat is sprayed. Computer graphics are sent to a plotter that cuts out adhesive vinyl paint masks. Any unneeded vinyl around the stencil is pulled away. This process is called weeding. Then, the vinyl stencils are pressed against the mask and the paper backing is peeled off. Applying a stencil to the crown is tricky because the surface is curved with ridges, so it doesn't lay flat. The technician lifts and cuts the pattern with a utility knife and then straightens it out. This mask is starting to look impressive. But the whole thing is covered with white paint. It's a temporary cover-up. This process is all about layering patterns and colour. More vinyl shapes are applied. Then, using a pressurized paint system, everything is sprayed bright red. Next, an artist airbrushes some shadowing on the now barely visible image of a leaf. Some of the vinyl is peeled away. The surface of the mask is sprinkled with water. Paint is misted over it, and the water droplets catch the paint. It's blasted with a heat gun. The water evaporates, but the paint dries in droplet form, giving the mask a frosted look. A drop shadow is airbrushed around some lettering. The technician dispenses with the usual safety gloves for this detailed work. And now, all is revealed. The vinyl is peeled away. Any flaws are touched up. The technician traces the pattern onto see-through paper and then transfers it onto board. He cuts it out with a utility knife. Then he aligns it with the shape on the mask and precisely airbrushes around it to make the smudge disappear. With the final clear coat, this mask makes a colourful statement. And now it's time to put all the pieces together. The stainless steel cage is screwed on. A little glue is applied to reinforce the adhesive-backed foam cushioning. The sweatband is attached with Velcro so it can be removed and washed. The harness is threaded through the back plate to the front of the mask. The harness is elastic, so it gives the mask some flexibility. Now it's ready to go out on the rink. And these completed masks scream, the puck stops here. So, whether you're after a bottle for your favourite tipple, or you want a little cutting-edge technology, or you need to save face on the ice, now you know how it's made.